Okay, so this is from March 31st. I'm just going through some homework questions. First question was, what's the difference between absolute convergence and conditional convergence? Well, this is something that is not on the AP exam for this year. It typically is, and I teach it in depth, but this year it's not really on the AP exam. We talk about it in 10.4 in Rogowski, and this is the definition of absolute convergence. Hold on one second. Evan, stop with the dice, bud. I'm teaching. All right. So I'll copy this, take a picture. Uh-oh. Oh, there it was. Bam. Okay. I'll take a picture of this guy. And we'll talk about whether it converges. So I'll give you an example. An example might be the summation as n goes from 1 to infinity of -1 to the n over n. Okay? So looking at this is called the alternating harmonic series. So let me just put that in, alternating harmonic series. So remember that the harmonic series was just the summation as n goes from 1 to infinity of 1 over n. And we talked about how that diverges. So I'm going to put that here. Recall that the sum as n goes from 1 to infinity of 1 over n diverges. And really that's, if you want to use a test, that's the p-series test, right? Because of the p-series. This is a constant over n to the first power. And we learned that if p is less than or equal to 1, then this will diverge. If p is greater than 1, meaning if that degree, right, whatever this is right there, that's not a 0, that's where the space is. That will, if that power is greater than 1, then this will converge. But here, p is equal to 1, so this diverges. Anyway, getting back to just this, example, talking about how it converges or if it diverges. First of all, we see that this is an alternating series. We see that the non-alternating part of this series is just 1 over n, which decreases, meaning that the n plus first term is always less than or equal to the nth term. And we see that the limit as n approaches infinity of the non-alternating part, which is just 1 over n, goes to 0. So this guy, I would say, converges by the alternating series test. Okay, so this guy converges. So a lot of times we're done. Hey, it converges. That's good. However, there are times, and again, it's not for this AP exam because they're not putting it on there, but there are times where they would say, yeah, but how does it converge? Does it converge absolutely or conditionally? So if you know that it converges, it either converges absolutely or conditionally. Those are the only two options. And what it means to converge absolutely is defined up here. A series converges absolutely if...
I didn't get that. Could you try again?
This always happens. As soon as I say series, it says, it thinks it's Siri, and then it like talks to me. Where was I? Oh yeah. So I'm going to look at the summation of the absolute value of this term and see if that converges. If that also converges, then this original series converges absolutely. So I'm now going to look at, so let's say look at, the summation as n goes from 1 to infinity of the absolute value of -1 to the n over n, which is really just the sum as n goes from 1 to infinity of just 1 over n, because I'm getting rid of the thing that makes it negative, right? -1 to the n is just -1, +1, -1, +1. So if I get rid of that, I just have 1, 1, 1, right, in the numerator. The denominator is just n, and I don't need an absolute value mark about that because n starts at 1 and keeps increasing by 1 all the way through infinity. So I look at that. Well, this guy diverges because of that, right? We already talked about that. So if I know that this original series converges, yet the sum of the absolute value of those terms diverges, that gives us that this, therefore, this series converges conditionally. Also known as it is conditionally convergent. And I'm sure we have a definition in Rogowski for that. So let me go to his book. An infinite series converges conditionally if the original series converges, but the sum of the absolute value of the terms diverges, which is exactly what we have for this example that I talked about there. Okay? So that's it in a nutshell. I don't really want to get too much more into it right now. I usually would, but it's not on the AP exam. That's something that was omitted, taken out, and so that just kind of gives you a little bit of an understanding. Does that work for you, Kayla? Cool. Anything else from any of the homework assignments that I've given you? So I'm not really teaching anything new today. I'm just going over problems that you might want to see or have questions on. Get you going in the right direction. Awkward silence. I hope you're not waiting on me because I'm waiting on you. The question is, are there any problems from any of the assignments that I've given you up until this point that you would like me to talk about, do for you? Number 7 from the Stewart problems. Sure, let's check that out. So I have the Stewart problems up here. So number 7 has arcsine. We want the 3rd degree Taylor polynomial. So we want the 3rd degree Taylor polynomial for arcsine centered at x equals 0, right? Because they say that a is equal to 0. So this is where it's centered. And this tells me it's 3rd degree. So t sub 3 of x, no matter what function I'm given, is always going to be f of a, which in this case is f of 0, plus f prime of 0 times x minus 0 to the 1st power, plus f double prime of 0 over 2 factorial times x minus a squared, plus the 3rd derivative of f evaluated at 0 over 3 factorial times x cubed. Sometimes I just put 6 here, but I like to, in fact, I'll put a factorial under the for 2 factorial. And while we're doing it, right, this is really where it comes from, right? So the 0th derivative of f evaluated at 0 over 0 factorial times x to the 0th plus the first derivative of f evaluated at 0 over 1 factorial times x to the first. Plus, anyway, so this is what t sub 3 is, no matter what we start with in terms of the function. Okay, so I don't know where I'll put you over there. All right, so now as my little side work over here, f of x equals arcsine of x. What's the derivative of that? What's the derivative of arcsine of x? It's that guy, right? Also known as, so I'm going to say f prime of x is also known as 1 minus x squared to the negative 1/2. I think that's going to make it easier for us if we look at it like that for the higher derivatives. So f double prime of x is equal to, it's going to be negative 1/2 times 1 minus x squared to the negative 3/2 times negative 2x. So f double prime of x is just going to be positive x times 1 minus x squared to the negative 3/2. So that's the second derivative. And then the third derivative of f of x, which I'm glad that it was only to degree 3 because I could see these getting more and more complicated. Just going from the second derivative, taking the derivative of the second derivative, I can see I'm going to have to use the product rule with the chain rule also. So I'm going to say, I think I'm going to need more space. So I'm going to extend this out over here. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. Okay, so really f triple prime of x is going to be the negative 2 is going to cancel with that, and I'm going to have, what is that, 3x squared times 1 minus x squared to the negative 5/2 plus 1 minus x squared to the negative 3/2. If I make a mistake, unmute yourself and tell me that I'm messing up somewhere, but I think I did that correctly. Anyway, so I have that t sub 3 of x is now going to be equal to, so f of 0. So what is arcsine of 0? Meaning sine of what angle in radians is equal to 0. And what is that?
0.
Yes! I got someone. Good, so that's going to be 0. So I don't need to put that term, well, I'll put it. Plus. Okay. F prime of 0. What is f prime of 0? So if I plug 0 in for x, what do I get?
One.
Good. 1x, right? So plus x plus something over 2x squared. So what's f double prime of 0? F double prime of x is equal to this guy. But when x is equal to 0, what does that whole thing become?
0.
Yeah. Plus something over 3 factorial, which is 6. Well, I'll just leave it like that, times x cubed. So what is f triple prime of 0? Well, that goes to 0, but this is just equal to what?
1.
1. So t sub 3 of x is just equal to x plus 1/6 x cubed. This right there is the third degree Taylor polynomial for f of x equals arcsine of x, centered at x equals 0. Cool?
Thank you.
Okay, so let's just see what that looks like graphically. You know, I know we've done this a few times. Here we go. So let's make it be arcsine of x. And then I'm clear this. Here I had, what was it? X plus 1/6 x cubed. Is that what I ended up getting? Yeah. So let's go ahead and let's do just Zoom 6 for now, Zoom standard. Okay, so remember, my red is my approximating guide, but the blue is the actual. So when I go to the graph, let's zoom in right at the origin. Okay, remember when we talk about the domain and range of arcsine of x, right? It's just gonna look like that. But hey, look at that. It's a pretty darn good approximation. The red is a pretty good approximation for the blue, except it starts, you know, the error becomes greater over here, but overall it's a pretty darn good approximation. And in fact, it is the best possible polynomial of degree 3 or cubic function that approximates this original function, which is, you know, arcsine of x centered at x equals 0. Okay, so that's what we just did. This was kind of the graphical representation of it, but this is like the procedural or more algebraic way of getting there. Okay, did that help you, my main man, Tyler Lentz? Anything else? Keaton asked for page 557, number 31. So that is in Rogowski. So that's section 10.2. Number 31, huh? One moment. Okay. Okay, and this tells us to use the formula for the sum, sorry. Where'd it go? Use the formula for the sum of a geometric series to find the sum or state that the series diverges. There it is. Everything's taking a while today. All right. So the very first thing I would do is apply the denominator to each term in the numerator. And when I do that, I'm going to get that this thing is equal to the summation as n goes from 0 to infinity of 8 over 5 to the n And then let's make another summation. Plus the summation as n goes from 0 to infinity of 2 to the n over 5 to the n, which is the same as 2/5 to the n. Okay, so now this is equal to 8 times the summation as n goes from 0 to infinity of 1 over 5 to the n, plus the summation as n goes from 0 to infinity of 2/5 to the n. Now, I can clearly see that this is geometric and this is geometric, and both of them have a common ratio that is in between -1 and 1. So each of them will converge. You multiply by just a scalar, by just a constant, and then you add them, and so this whole thing will converge. So I can right now state that this will converge, right? Because it's just a, couple of geometric series there. And the next thing is determine what it converges to. Well, again, I would say that this converges to, so I would say, instead of equals, I would say converges to 8 times. So now I have that first term divided by 1 minus a common ratio. And then over here, it's first term divided by 1 minus the common ratio. So this is 8 times, this right here is 4/5. So 1 over 4/5 is 5/4. This right here, 1 minus 2/5 is 3/5. So that's going to be plus 5/3. Now, 4 goes into that once, into that twice. So I'm left with 10 plus 5/3. Well, 10 is 33, so you can say 35/3, or you can say 11 2/3. Did that make sense? And so I believe I've mentioned it in the past, but with the geometric series, a lot of times you just have to manipulate the general term so that you can see what that's gonna look like in terms of geometric. And in this case, we saw, oh yeah, that does look like just a couple geometric series added together. Okay. Okay. What else would you like to see? Let's look at number 34, Keaton. Yeah, so for just number 34, let me just do it. Get you started. So for this guy, in order for it to be geometric, you could always take any term divided by the one before it to get your common ratio, if it is geometric. Now, for me, I would just look at it and say, well, going from term to term, I'm multiplying the numerator by 2, right? And I'm multiplying the denominator by 7. And so I can see that R is going to be 2/7. Do you see that? And so that tells me that this series will converge. And so this guy converges to the first term divided by 1 minus 2/7. But what is a first term? Well, they give us a first term. It's just that guy, which is 8/7. The first term is just 8/7. They give us that. And we saw that the common ratio is 2/7. Those are the only two pieces of information that you need to know. If you're giving it to geometric series, you need to know the first term and the common ratio, because that series converges to the first term divided by 1 minus a common ratio. So now that I have that, I have 8/7 divided by 5/7, which is just equal to 8/5. Anything else? Like I usually say in class, don't wait for Thursday night to do all these so that you could turn them in on Friday. Make sure that you guys are going through. And the good thing is you guys have the videos if you wanted to see them, which I looked the other day, and let's refresh real quickly. So I realized that a lot of you were present with me, but there's only been 5 views for the part 1 and 3 views for the part 2 from Friday. And from the calculus notes from the 24th, which I believe was on Thursday? Whenever that was. 13 views and 11 views. So you're not really viewing all that much, which is fine if you're here and actually getting the notes, but just know that these are up here for you, and you can access all of these through my website. You know, you just click on any one of those. And then that's going to kind of help you out. If you're struggling and like, wait, what did he say? Everything is being recorded and posted. So you have this available to you. Okay. But don't wait for Thursday night to say, okay, I guess I got to do this because it's due on Friday. That being said, any other questions that you have on any of these assignments? I'm thinking about doing, yeah, Tyler, we'll do that. We'll go through some infinite series. The thing is, you know, we're being asked to, instead of all of series, like just do this and this and that. And so I'd have to go through actually and look at the AP exams, because I'm sure it has a lot more than just what we have to do and what I've taught. But anyway, but what I was going to say is before we get into that is on Thursday, I also want to have a session similar to today, today's session, where we go through and, you know, just I open it up for homework questions so that I can answer those questions before you do or have to turn it in on Friday. All right, so that's what we got going on. But if there are no other questions here, I think I'm gonna stop the recording and then just kind of go over a little bit about the Infinite Series AP FRQs from the past, just so we can see what they look like. So any other questions on the homework assignments or any other problems? Okay, I'm gonna say I'll be here Thursday at this 10:30 time slot, and it'll be a very similar thing. I'll post everything on Google Classroom, all the information to get on at the Zoom meeting, and then we'll reconvene on Thursday. If you have any specific questions that you just don't quite understand, or you're not sure about how to do, whatever it is, you can always email me and we'll go from there. Okay? All right, I'm gonna stop the recording here.